this question, I just say to myself, okay, this angle is in which quadrant? Is it in quadrant 1, 2, 3, or 4? Well, 2 pi over 3, let's go around. We didn't talk about that, sorry. So here, this is 0 radians. This is 90 degrees or pi over 2 radians when we rotate to here. When we do a half turn, that's 180 degrees or pi radians. When we do a 3/4 turn, that's 270 degrees or 1.5 turns or 3 pi over 2. And when we do a full turn, we get to a total of 2 pi because it's a 360, which is a radius, right? This is the circumference of a circle. So it's 2 times pi times r. The r is 1. So coming back to 0, we've done a full turn, which is 2 pi units. So 2/3 is not quite 1 whole, so it's going to be here in the second quadrant. So in my second quadrant, sign is positive, so I know that I'm going to get a positive, or I'm just going, I know it's pi over 3 because I can see that right here. It's my sign, which is my y coordinate, so my answer is √3 over 2, and it's positive because it's in the second quadrant. Cosine of 5 pi over 4. If this isn't making sense, just come and see me. Cosine of 5 pi over 4. I know I'm going to work with one of these two ordered pairs. 5 pi over 4, which quadrant is it in? Well, it's 1 1/4 pi, which is in my third quadrant. So in my third quadrant, cosine is negative. I also know cosine is associated with the x-coordinate, so it's negative 1 over √2 or negative √2 over 2. For my third one here, I have tan of 11 pi over 6. Well, I know I'm going to be working with this one here because it's a pi over 6. 11 pi over 6 is 1 5/6 pi, which is just shy of 2 pi, which means we're here in the fourth quadrant. In my fourth quadrant, tangent is negative, so I know my overall answer is going to be negative. Okay, now wait a minute. This is my x-coordinate, my y-coordinate. That means that's cosine and sine. Where's the tangent? Well, remember tangent is equal to sine over cosine. So I'm going to take my sine, I'm going back to this pi over 6, I'm going to take sine divided by cosine, so that's 1/2 divided by √3 over 2. The 2's cancel, so I get negative 1 over √3. And there you have it. It's way simpler than what I made it just seem. It's quite messy there, but again, talk to your teacher for some ways to remember. We don't memorize it. I mean, maybe you're going to have to remember this, but we're hoping you remember it from geometry days, these triangle relationships, and you're not really memorizing all this stuff. Okay, I've highlighted the two things that will be on the formula sheet. So the only thing that's on the formula sheet that we give to you is tangent, which is sine over cosine, and then this first Pythagorean identity, because you can create these two by dividing by sine squared theta and by dividing by cosine squared theta, or u. Everything else, though, you should know. All right, so what are some common questions we might ask from this first section? It says, example number 1, find the value of the 5 remaining trigonometric functions given that secant of u equals negative 3/2 and tangent is positive. So you might want to draw your coordinate system. Secant, which is related to cosine, is, so you could rewrite this if this helps you. Right? Flip that upside down. So cosine is equal to negative 2/3, but tangent's positive. So where will cosine be negative but tangent be positive? And that is going to be here in my fourth quadrant. When you draw this triangle, you need to draw it with the angle here between the x-axis and the radius. So that is how your angle needs to be drawn. We know that cosine is equal to adjacent over the radius, so it's x over r. So I get my negative 2/3. The only way I can find the other 5 trigonometric functions, or 4, because I found 2 of them, is to calculate the height right here, or the y value. So how do I do that? Well, I use Pythagorean theorem. So y squared plus negative 2 squared equals 3 squared. So y squared is going to equal 9 minus 4. So y squared is equal to 5. Y is equal to plus or minus √5. Well, we know we're going down, so you know your y is negative. So really, we're just looking at the negative √5. So now that I have my x, my y, and my r, I can go ahead and find the 5 trigonometric functions. So why don't you do that now, and then you can compare your answer with mine as soon as we are done. Okay, so hopefully you got this. Okay, moving on. Another thing you did last year was some simplification, writing expressions as a single term whenever possible. So here is our first example. We have sine cosine squared x minus sine of x. Well, what are you going to do? You should factor out anytime you can. So we're going to factor out the sine of x. So when we factor out the sine of x, you get cosine squared x minus 1 in parentheses. Then, well, what is cosine squared x minus 1? Well, that is Pythagorean identity. We're going here with sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. So then if we take the opposite of both sides, then you would get cosine squared x minus 1 equals negative sine squared. So sine times negative sine equals negative sine cubed x. So that is a single trig function. Try B and C on your own. Go ahead and pause and try them on your own. If you're not sure about what to do for letter B, well, oops, I just erased and showed you the answer. It's to convert everything to sine and cosine, right? So convert everything to sine and cosine. Try that on your own. So cosecant is 1 over sine, and then cosine times cotangent. Get a common denominator. You have that. Then you have 1 minus cosine squared. Well, what is 1 minus cosine squared? That's sine squared. So you get sine squared x over sine, and that equals sine of x. Letter C, you have to get a common denominator. So you're going to multiply 1 minus sine of x over here and 1 plus sine of x to this fraction. So your common denominator is 1 plus sine of x, 1 minus sine of x. Right, so that's what we do. These are called conjugates of each other. So when you multiply it out, you get 1 minus sine squared x. So we have 1 times 1 minus sine of x equals 1 minus sine of x. 1 times 1 plus sine of x equals 1 plus sine of x. You combine those, the sine of x is cancel. You get 2 divided by 1 minus sine squared x. But 1 minus sine squared x is cosine squared x. So we have 2 divided by cosine squared x. But 1 over cosine squared x is secant squared. So we get 2 secant squared x. Okay, letter D, we have a little hint for you right here. Log secant plus log sine, if they have the same base, but they do, then you can multiply these two things together. So we would get secant x times sine of x. Well, remember secant is 1 over cosine, so that would be log of sine x over cosine x, which is log of tangent x. Absolute values, why are they there? Think about it. If you're not sure, talk to your teacher. But think about, why is there an absolute value? What is the meaning of that? Our last question, you have to get it so it's not in fractional form. Your only option is, this is my hint, conjugate. So pause and try it on your own, and then you can compare your answer with mine when you're done. So multiply by the conjugate. Then we get cosine times 1 plus sine divided by 1 minus sine squared, but 1 minus sine squared is cosine squared. The 1 cosine cancels with the cosine squared in the bottom. One of them is left. So we can separate, right? So 1 plus sine over cosine, we can go 1 over cosine plus sine over cosine equals 1 over cosine is secant, and sine over cosine is tangent.